Hello, welcome back to our tutorial. Today I'm going to share to you Hess law, Hess law diagram, which is the definitions of Hess law is actually the total enthalpy change in a chemical reaction, which independent of the route by which the chemical reactions takes place. So it doesn't really, you don't really care about the route, but you have to consider the uh, first and last state. And in order to manipulate the rules of order Hess diagram, so you have to consider three things. First one is actually you have to consider that the equations can be reversed. So when reversed, the sign of delta H needs to be reversed as well. So for example, you have a H2 plus O2, all right, to give H2O. So if you look at the equation, you have different number of oxygen. So I put half here to balance the number of oxygen on the right hand side. Now let's say the information given to you that value of delta H for this HF formations of water, let's say it is minus 154 kilojoule per mole. It is only for example, this is not the real value of delta H for water. Now if you wish to manipulate the equation by reverse the reaction. So you can actually write H2O to give H2 plus half O2. Then if you do that, then the value of delta H will be positive. So now you have a 100 kilojoule per mole, right? So that's the understanding for the first point. The second point, formula can be cancelled from both sides of an equation only if substance is in the identical physical state. So we'll get this one later. Okay, I'm going to explain this point when I answer these questions. Okay, question number one. Okay, and number three, if all coefficients of an equation is multiplied or divided by the same factors, the value of delta H must likewise be multiplied or divided by that factor. For example, if you say that this reaction, the formations of water is actually, for example, 154 kilojoule per mole, but you need to have a 2 mole of water. So when you multiply this water by 2, meaning you also multiply this one by 2, all right, and then if you multiply that half, then you'll have only one. So excuse me, so you have only one oxygen, all right, and then as a consequence, so you also need to multiply this value by 2, all right, so you'll have a 8, all right, 10, 1, and 3. Okay, so if you multiply the value of mole here, then it will also affect the value of delta H, right? So how about if you divide? So you just divide this one by 2. So for example, this one you only need, for example, half of it. So this one also divided by 2, and it will give you a specific amount of energy, right? Okay, so let's do questions number 1 here. Okay, so number 1, so you have a C plus O2, okay, excuse me. So C plus O2 to give CO2, and then it is actually the value of delta H1, and then you have a CO plus half O2 to give CO2, which is delta H2, and then you also have a C plus half O2 to give CO. Sorry for that box actually the arrow, then it becomes delta H3. So how do we resolve this problem, right? So first, let's draw the Hess cycle. So basically, I can see that there will be like transformation from CO, okay, plus half O2 to give CO2, all right? Okay, so and then I have as a reactant here. So basically I can see that the delta H2 is actually the product of delta H1 and delta H3. So I'll just put a reactant on at the bottom. All right. So if I go this way, so it is actually delta H3. All right. So because delta H3 is actually C plus half O2 to give CO. All right. And then this way is actually delta H1. Okay, delta H1 is C plus O2 to give CO2. So this is actually delta H1. How about this one? I have delta H2. All right. So if I wish to complete, then I will complete this one. It's actually G, and this is actually S. So this is the Hess diagram for Hess cycle from the questions number 1. So you only need to see which one that you think that you have a product, right? So a molecule from its element. So here you have an element CnO2 to give CO is actually the compound, and C plus O2 to give CO2, which is actually also compound. So when we draw this one, then you can actually have an equation. Delta H1 equal to delta H2 plus delta H3. All right. So if you wish to find delta H1, then it is actually the additions between delta H2 and delta H3. All right. I hope that's I hope that one is clear for you. All right. And then if you look at question number 2, excuse me, if you look at question number 2, then we can see that here we have a reaction between ammonia and oxygen, okay, to give nitrogen monoxide, and also I have a water. Okay, so how do we draw the Hess diagram for this one? So basically you just write here. Okay, so we have a ammonia, right, 4NH3 plus 5O2 to give 4NO and then 5 water. Sorry, 6 water. Okay, so there will be 6 water molecule that we have. Okay, so 6 water. So look at this one. You have a molecule, all right, or compound, whatever your definition is actually. So this also a compound, right? So we have a compound, compound, and compound. So basically you can put underneath for this equation is actually the elements, right? So you have N2 for nitrogen. What else you have? Okay, you have also hydrogen. What else you have? I have also oxygen. Okay, so this one should not be created because this one is actually a element. We can only put a Hess cycle for the compound. All right. So H2 plus O2 is actually H2O. All right. So because I have a 6 molecule of water, then I need to multiply by 6. All right. So it's actually the method that I already mentioned to you is already submitted to the point of rule manipulation in number 3. Okay. How about NO? So it's actually N2 plus O2 to give 4 NO. So that's why I also multiply this one by 4, delta HF NO times 4. All right. And then if you go here, so you will have a formations of ammonia. All right. So it's actually formations of ammonia from nitrogen and hydrogen to give 4 molecule of ammonia. So I will write delta HF times 4 because I have basically I have 4 moles because from the coefficient I also have 4 because I have 4 molecules of nitrogen monoxide, and then I have 6, and then I also multiply by 6. All right. So that's the how you do or draw the enthalpy profile diagram for Hess law. Thank you for watching.